Please welcome Corporate Vice President, Cloud AI, Dr. Joseph Sirosh.
Good afternoon. AI is the new normal. Every type of software application is integrating AI. Cloud APIs and cloud services make it very, very easy. Let me share a small story to illustrate. HelpPicto is an application developed by a French company, a small startup called Equidex. It's an application that allows mothers to communicate with autistic children. Now, the standard of communication today is to create a pictorial communication. Take pictures from a book, assemble it into a conversation, and show it to the child at the same time as speaking it. That ensures the child understands what you're trying to say. Very clumsy, as you can imagine. So this enterprising developer used cloud-hosted APIs and built an amazing application on a mobile phone that understands what the mother speaks, translates it into a visual conversation on the app, and you can now show that in real time to the child. Let me play a video to illustrate.
Arthur, c'est un autiste sévère qui n'a pas de langage et qui a 15 ans.
Pour aider les personnes avec autisme à communiquer, il y a des images. Donc ça peut être des photos, des pictogrammes.
Le classeur, le PEC, c'est pas quelque chose d'évident, de facile. On n'a jamais la bonne carte. La bonne carte, elle est perdue, elle est tombée sous le fauteuil. D'où l'intérêt pour lui de communiquer avec HelpPicto.
Le départ d'HelpPicto, c'est des discussions que j'ai eues avec Karine, qui avait une idée depuis quelques temps, mais c'est devenu possible depuis quelques mois. Microsoft a développé ce qu'on appelle des cognitive services, mis à disposition dans le cloud, et qui vont permettre d'exploiter des choses qui étaient très difficilement exploitables auparavant. De la reconnaissance d'images, de la reconnaissance vocale et des traducteurs automatiques de langue. Et ça, c'est important parce que c'est nous donner la possibilité à nous, PME, d'accéder à ce qui se fait de mieux en matière d'intelligence artificielle.
Je parle, je donne une information à Arthur et elle est traduite par l'application HelpPicto instantanément en pictogramme et après d'une façon orale.
Va t'habiller et te brosser les dents.
Ce qui est intéressant, c'est qu'il y a une interface qui va ensuite transiter dans tous les milieux de vie de la personne. Ça permet de développer de l'autonomie personnelle, de l'autonomie domestique, participer à des tâches. C'est un outil qui est évolutif.
On a eu la chance d'organiser avec Microsoft un Helpfest, une sorte d'hackathon, où pendant 3 jours, on a été immergé dans une salle de réunion où on a fait quasiment 24 heures non-stop de développement. On y est rentré avec une idée, on en est sorti avec une solution. On est une petite société, on a 40 ingénieurs qui travaillent sur plein de domaines divers et variés. Il nous faudrait des années pour pouvoir construire une solution identique. Aujourd'hui, on a besoin d'une architecture qui est la plus petite possible avec le coût le plus bas possible. Donc on s'appuie sur Azure pour ça et faire en sorte que demain, quand on va atteindre des centaines, des milliers d'utilisateurs, j'espère, on puisse juste appuyer sur le bouton et puis augmenter la charge serveur, la ressource disponible d'un claquement de doigts. Plus on utilise HelpPicto, mieux ça fonctionne. Le modèle va continuer à apprendre au fur et à mesure pour faire en sorte de l'optimiser et de le spécialiser.
On va pouvoir remettre en place une communication qui est plus spontanée. Donc en termes de qualité de vie, ça c'est absolument énorme. Je crois que ça aide à recréer du lien.
C'est beaucoup plus ludique, plus facile, comprend mieux. Ça paraît pas grand-chose, mais en fait c'est énorme cette différence. C'est vraiment énorme.
Just huge. That's the difference AI makes in communication, in understanding, in handling media. An application like this would have taken developers such as you many, many years of work and perhaps help from lots of researchers before you could build and deploy this. Even 2 or 3 years ago, it would have been very, very hard to do. But now with cloud-hosted APIs, APIs for speech recognition, vision, captioning, and application developing environments like Xamarin, you can build these very powerful cross-platform mobile AI applications. So here is a rough outline of the architecture. Data such as pictures that the mother takes from around the house of cups and water and the things that she wants to communicate. They are all uploaded into the cloud. Using computer vision APIs, those images are captioned, and so you can understand the content of those images. Now, they use speech recognition. So when a mother speaks, her voice is translated into text. And then from the text, you can take keywords and match them with the captions. So you can pull the right picture out and then lay that out in a sequence to show it to the child. And so integrating all of this in a flow suddenly became easy without you having to build these very sophisticated capabilities of AI. So the AI services in Azure that make all this possible, they're all about bringing the best of AI to developers on Azure as cloud-hosted APIs, and at the same time bringing the best of Azure's capabilities, cloud innovations, to AI. Cloud innovations such as the latest in hardware, cloud innovations such as microservices and Azure Kubernetes service for hosting these Docker containers. Bringing all of them together is what the Microsoft's AI platform is all about. There are three major groups of AI services. The pre-built AI services, which is very accessible to developers. They cover a very broad swath of pre-built capabilities like speech recognition and translation and visual captioning and face recognition, and a very large number of these, like 35, an ever-increasing number. Then there is the conversational AI capability. The Azure Bot service to help you stand up very powerful interactive conversational applications and chatbots. And it's all hosted in the cloud. And then for the sophisticated machine learning developers, those who want to build custom AI models from their own data, such as for most top-tier enterprises, we have a custom AI development environment with Azure Machine Learning. So let me now talk about how developers use these services. And over the course of this presentation, you will see multiple demos. So developers build modern applications with AI, applications that can truly understand and interpret the meaning of data, including text and voice and images like you saw with the Helpik 2 application. Now, another use case is to build conversational applications. So you can engage with users in natural ways. Remember, still the vast majority of the planet doesn't type very well. Wouldn't it be great if you can have a conversation instead with the user, instead of forcing humans to think like computers or act like computers want them to? And that's what conversational AI allows you to do. And then the third major use case is that developers build AI to optimize business processes. So you can reason and learn and form conclusions from data of your business, and then change your workflow and make it more efficient and make it run faster. So Azure Cognitive Services, let's start with pre-built AI. They're powerful pre-built AI models exposed as API services. They're simple REST APIs with .NET, Java, Python, and Node SDKs. And a unique feature of many of these APIs is that they're customizable. This is one of the biggest differentiators of Azure, by the way. So you can train a speech recognition model with your acoustic model, with your own language model for your own domain, so that it accurately understands speech in that particular setting. You can train in the cloud. Many of these APIs allows you to train in the cloud and export models to deploy on the edge. Unique differentiator. Over 1 million developers are today using Azure Cognitive Services and creating amazing applications that we wouldn't have even imagined. This is what innovation does. It frees our imagination and helps us build amazing new experiences, software that's very different from what has come before. So today, I'm actually excited to announce about 10 new features we have launched at Build in Azure Cognitive Services. The first one, the Computer Vision API. It now has a vastly expanded capability to do object detection. You can recognize thousands of objects, and you can even localize in an image a particular type of object you want to detect. Then we have Video Indexer in Preview, an amazing service which can ingest videos and can transcribe the speech and understand the video itself and index it and segment it so you can go very quickly, precisely to where you want to go in the video. We have a unified speech API, one of the best in any cloud, with customization. Train it with your accent, train it with your vocabulary, train it with your language model. We have now speech synthesis with a unique innovation, a customizable voice. Imagine if you could make the computer speak in the voice you wanted it to. I can even train one to talk like myself, God forbid. There's speech-to-speech translation. You can speak in one language, you will hear in another language. There's text analytics with entity detection. Key entities can automatically be detected in text, and that allows you to cross-link it with other documents and with the web. Now, the language LUIS has an integrated offer that integrates many other capabilities, like spelling correction and bot framework, etc., along with it. And then there's a wonderful service called Q&A Maker, which you should all explore. It allows you to make chatbots with FAQs. Most of us have FAQs, questions and answer pairs. And if you want to create a model that allows you to ask a question over chat, one of those frequently asked questions, and get the answer, Q&A Maker makes it very simple. And then there is Bing Visual Search with smart identification. So you can search with images, upload an image, or point it to an image. You can use that image or even a portion of it to search the web with it. Powerful features, examples of the wide variety of things AI can do. And then finally, Bing Search SDK is generally available. You know, this is a very rare thing. You have the entire power of Bing available through an API to integrate with your applications. You can search the web. You can search news. You can have even custom search pointing to specific websites. You should explore that. It's one of the most powerful APIs available, period. So those are the 10. And now when you bring all of that together, these kind of APIs together, with a capability like Azure Search, which allows you to index and search your own private data, then again something magical happens. You have Azure Search with cognitive services that allow you to enrich the content that you would put into a search index. You can take images, understand what's in the image. You get visual captioning. That can get indexed. You saw a demo of this in Satya's keynote with the NBA, in Scott's keynote with NBA's use case. So it enables immersive search experiences over any type of data. It's so powerful, and customers who we have shown to are incredibly excited about bringing very rich unstructured data, transforming it using cognitive search, and making it all searchable. And they are also even thinking about the AI-enabled ETL process. So when you bring all the data in, why not apply AI to that data and take the rich knowledge so extracted and make that part of your data lake, for example? Very, very powerful. The best way to see the power of all of this is with a demo. So let me invite Brian Smith, who is a principal engineering manager in my team, to show you a wonderful demo of Azure Cognitive Search. Brian?
On November 22nd, 1963, the President of the United States, John F. Kennedy, was assassinated. While driving through the streets of Dallas in this motorcade, he was shot by a lone gunman named Lee Harvey Oswald. At least, that's what the government wants us to believe, right? In fact, this subject has been the source of so much controversy that 25 years ago, an act of Congress mandated that all documents related to the JFK investigation be released to the public by 2018. So how many documents are we talking about here? To date, they've released close to 50,000 pages, spread across thousands of PDFs. Are any of you curious what's inside them? I know I am, but that's a lot of reading to do. So how should we approach this? Whenever you want to extract knowledge from an unstructured source of data, it's best to use a continuous process that ingests it, enriches it, and then lets you explore the data. Starting today, there's a powerful new way to do this in Azure. Cognitive Search. Cognitive Search is a set of capabilities in Azure Search that lets you use and compose cognitive skills to extract knowledge. Cognitive search ingests your data from almost any data source and enriches it using these cognitive skills. It then lets you explore the data using search. To demonstrate this, I've uploaded thousands of these JFK documents to Azure, and I've used cognitive search to enrich them. So join me as we open the JFK files. This is the JFK files. On the left, you can see here that the entity skill has already extracted all of the people, the places, the organizations inside of all these documents. On the right, you can see all of the raw content from the files themselves. But let's start from the beginning with Oswald. Now, right away, you can see that we're pulled to the exact part of each document that contains Oswald. And this is because an OCR skill has annotated every single word in the document with the specific location that this word was found. You'll notice that we can find Oswald in typed and in cursive and in photos and in handwriting. Did you notice the GP floor was highlighted here as well? This isn't a typo. In fact, the CIA often uses code words in their communications, with GP floor being a cryptonym for Lee Harvey Oswald. This annotation was added by a custom skill that I created using a published list of CIA code words to detect cryptonyms. Now these words are linked together and they can be treated as synonyms. Now let's take another look at this photo that we saw. Now nowhere in this photo is the word Oswald, but because the computer vision skill analyzed this image and recognized his face, it was able to give us this caption here, which is Lee Harvey Oswald posing for the camera. It's not exactly what's going on, but it's pretty close. Now, even though the government released all of the documents, in some of these documents, they still redacted the words they didn't want you to see. So let's find those documents. And with just one click, here they are. Now, how did we do this? As powerful as the Cognitive Services custom vision skill is, there's no way that the default vision service understands what redacted documents are. So I partnered with a data scientist and we built a custom redaction classifier in Azure ML. I then used the cognitive skills extensibility in cognitive search, and I added my own custom redaction skill to the skill set. And it was able to find these documents within minutes. Even this document over here, where they didn't even use a dark enough marker. Now, let's look back at these entities. If you look at all of these entities, there's one entity that doesn't really fit in. Cuba. Why is Cuba in the JFK files? Well, Oswald was linked to Cuba, but in the 1960s, there was all sorts of drama going on between the United States and Fidel Castro. And it turns out that the CIA ran a top secret operation against Fidel Castro. So let's find out more. So here you can see it's returned a bunch of documents describing this thing called Operation Mongoose. Now we could go off and we could read all these documents, but let's take a look at the relationships that emerge when you enrich your content with cognitive search. Now, without reading any of these documents, I can see some key details of this operation emerge. In fact, Operation Mongoose is when the CIA hired the Chicago Mafia to kill Fidel Castro using none other than poison pills. Now, it is incredible to believe that I did not just make that up, but what's even more incredible is how cognitive search was able to find all of these details and relationships without having ever seen any of this content before. Now, when the government releases a top secret set of files associated with the assassination of a president, you better hope that your name is not in there. Fortunately, mine is not. I did check. However, one of our product names is in here. No, SQL is never part of the controversy. But it turns out that the CIA used SQL in 1997 to try to manage these very same documents. In fact, they were kind enough to give us this wonderful architecture diagram I found that includes such powerful things as phone lines and secure modems and some fantastic 90s clip art. Well, a lot's changed in the last 20 years. So let's take a look at the architecture of the cognitive search solution that I showed you today. Though I am going to have to use that top secret clip art. First, the documents are uploaded into Azure Storage. Next, Azure Search does all the heavy lifting to continuously extract the content. Then all of the built-in skills that I've configured run automatically, and in addition, it also runs 2 custom skills that I created, redaction and cryptonyms. Then finally, all of that data is ready to explore inside of Azure Search. Now let me show you how easy it is to get started using Azure Search with Cognitive Search. Here we are in the Azure portal on my JFK Files dashboard. Let's jump into my Azure Search service. To get started with Cognitive Search, on the Overview tab, select Import Data. Here we select our data source. Azure Search supports SQL, Cosmos DB, blob storage, and table storage. But for the JFK files, I already have an existing data source that I'm going to use. Now, this isn't just a one-time import. We're going to be able to continuously pull data from this data source whenever it changes. Right now, it's looking at the data, and it's extracting the schema of the data to prepare for the next step. So here we are at the new Cognitive Search blade. This is all you need to get started using Cognitive Search. It includes everything you need for OCR for images and PDFs, as well as all of the skills to extract people names, organizations, locations, key phrases, and detect languages. Now, all of these enrichments will just be in your index. That's all you have to do. But the portal is only the basic experience. We actually have 6 more built-in cognitive skills, including image analysis, sentiment, and Web API extensibility. So let me show you what Web API extensibility looks like inside of Cognitive Search. When you add Cognitive Search to an index in Azure Search, we create a description of the skills that you use that we call a skill set. The skill set is a JSON representation of how all the inputs and outputs of all the skills work together to create new document fields in your index. If you want to add a custom skill to your Cognitive Search index, you need to update that JSON. So let's take a look at how I built this custom redaction skill. So all custom skills in Cognitive Search need to set 4 properties. The first is the URI. This is your custom endpoint that you're going to use for your skill. The next is the inputs. These are the document fields that you want passed into your skill. In this case, I want image data to come from my normalized images. The next is outputs. These are the new document fields that you're going to create as part of your skill. In this case, the redaction score that I'll compute. And finally, the context. The context tells us where to put the outputs in the enriched document. So now every normalized image will have a redaction score. So let's take a look at the function behind this skill. It's super simple, so let me walk you through it. First, you just parse and validate the request. Next, I create a redaction classifier. And finally, I create the response for the image. In order to create the response, I read this image data field that I just showed you. I classify the image here, and then I simply write the result to the redaction score output field. And that's it. And so what's exciting about this example is that it really just scratches the surface. Because when you use the built-in cognitive skill capabilities combined with extensibility, it enables you to express incredible amount of enrichments on almost any type of content. Today I showed you how Cognitive Search can solve a problem the FBI might have. But imagine how Cognitive Search could be applied to your data or your customers' data. Whether it's analyzing legal contracts or understanding engineering plans or extracting forms information, you can now leverage the Cognitive Search capabilities of Azure Search to easily extract structured knowledge for use in your applications and services. Right now, you can get started in the portal, and because Azure Search works across storage, SQL, Cosmos DB, and most major file formats, chances are it can work on your data wherever it already is. And of course, everything runs in your subscription. Everything else I showed you today, including all the sample code for the full JFK Files website and the custom skills, are posted on GitHub. So you can go clone this repo and within minutes create your own JFK Files experience on your data. With Cognitive Search, it's never been easier to bring the full power of cloud and AI to your data. Tomorrow here at Build, we have a full breakout session just on Cognitive Search. Here we'll be showing you what some of our private preview customers have built with it and how you can build with it too. So go check it out and get started unlocking the knowledge hidden in your data. Thank you.
So now let's talk about conversational AI. So the Azure Bot Service makes it incredibly easy to host a bot. It integrates with a number of language understanding capabilities. It provides you the capabilities of the bot framework. It allows you to build sort of a bot brain and host it. And the bot brain then can interface to customers through channels, through Facebook, through Slack, through web chat, a very large collection of channels. So what's a bot really? Now, 300,000 developers are using the bot service, by the way. And a bot is, at the end of the day, a collection of channels to have the interaction. Then your logic, your conversational and business logic, the bot framework to help orchestrate a lot of that and the bot service, and then intelligence, AI, added with cognitive services. So you bring all of that together and design a wonderful, intelligent assistant for yourself. Now, maybe the best way is to share an example from one of our customers. Telefonica is one of the world's largest telecommunications providers. They've created an amazing personal assistant using the Azure bot service called Aura. Let me play a video.
Okay, Aura. Our conversational AI, Aura, lets us put people first.
We are using artificial intelligence to change the way we are relating to customers. One of the reasons we began to use Microsoft technologies was because it offered an open framework.
It was very easy for all my development team to understand the tools.
We can very fast and very easy move into the use cases we want to develop for our customers.
Using tools like Azure Bot Service and Luis, we keep getting new insights and we are applying them into our core business. Microsoft AI was a key piece in our strategy because they have the tools, the platform, the full ecosystem that we needed.
Great. So now let's go to some actual demo examples. So you just saw the wonderful JFK Files demo and the cognitive search capability. So the cognitive search capability allows you to digest all of this information and digest it with AI. So what if you could put speech recognition on top of that, of all of that understanding? What if that was speech recognition trained with the custom speech API so that it understands the terms, those complex terms in JFK Files, like GP floor and RIBAT, and there are lots of government terms. Speech recognition should be able to understand that, right? And custom speech makes that possible. Then you build a chatbot with the Azure bot service. And then wouldn't it be great if that chatbot can actually speak to you in a voice? And imagine you could create your own voice, custom voice, and it speaks to you like you want it to. Well, let's see that. Let me now invite Noel and Wilson, who are from my team, to show you this amazing experience that we can build on top of JFK Files. Noel?
So the year is 1963, and Lyndon B. Johnson has just been appointed the new president of the United States. You would have a ton of questions, right? Who would you want to talk to? Probably the head of the FBI. Well, as it turns out, the JFK Files happens to have a recording of an early conversation between Lyndon B. Johnson and the head of the FBI at the time, Mr. J. Edgar Hoover. So why don't we take a second and listen in on that conversation.
How many shots were fired? 3. Any of them fired at me? No, there was no. All 3 at the president?
All 3 at the president, and we have them. There's been some stories going around in the papers and so forth that that must have been more than one man, but because no one man could fire those shots from the time that they were fired.
Interesting. The voice you just heard was J. Edgar Hoover's voice. Wouldn't it be cool if we could chat with J. Edgar Hoover? Maybe. So we thought it might be, with the power of the JFK Files and Microsoft AI, we thought we'd have a little bit of fun. So we created a bot, but not just any bot, the J. Edgar Hoover bot. So why don't we give it a try? Mr. Hoover, welcome to Build 2018.
Here. Thanks for having me. How can I help you?
That was a custom voice, a synthesized voice that we used, that new custom voice service. It's actually a feature of the new speech service that was announced today. You actually heard Joseph talk about it. But it's not enough that our bot sounds like J. Edgar Hoover, though that was very fun. We also want it to know what J. Edgar Hoover would know. We wanted to understand the words that J. Edgar Hoover would understand, these code words, right? These cryptonyms. So the JFK files have provided us a bunch of knowledge, right? We've now used this feature, cognitive search, to be able to locate that. Great, so now our bot knows that. But it's not a delightful, fun conversation if the bot, when I speak to it, has no idea what GP floor means or any of these other code words. Speaking of which, let's see, I tried to plant it, so I'm gonna ask you guys in the front row. Does anyone remember the code word, the cryptonym associated with Oswald? Yes, sir, thank you, thank you. All right, and I even got you a cool t-shirt. Yay, awesome, good job. See, it pays to take notes in here, people. Awesome. So he said Oswald, right? So that's great. So GP floor is this super, like it's pretty important in this JFK files example. So what we want to do is just kind of test out this bot and see if it understands this special word. Mr. Hoover, show me the #1 cryptonym associated with GP floor.
KPOP. It is the table indicator for the highest level of document sensitivity. KPOP is above right hand, which is above eyes only.
Above eyes only? Like ears only? Like stuff you'd only say or maybe whisper to your friends, right? So we've now got Oswald and super secret. But before we get into that, I know you're super interested in that, but before we look at the magic that just happened here, right? When I said GP floor, it understood what that meant. It didn't write, which is what the typical language model would do, which is the language model takes my speech and translates it into text so my app can do something. It would typically say little g, little p, space, floor, like the floor I walk on. That's what it would think. But that's not what I wanted it to think, so I needed to customize it. So I customized it and said, no, when someone says GP floor, what I want you to do is I want you to show that. And that's true for all the cryptonyms, right? There were hundreds. And then you saw it, of course, could come back, and that synthesized voice, J. Edgar Hoover never said that thing that we typed out, that was found in the JFK files, right? We're using our synthesized voice to say that. So going back, right, we've got this really great idea of like GP floor, which is Oswald. We've got KPOC, super secret. What's a question that maybe I could ask that qualifies, you know, that maybe falls into that category? All right, I have an idea. Mr. Hoover, oh goodness. Mr. Hoover, did Lee Harvey Oswald do it?
Here is a memo that I wrote. The thing I am concerned about is having something issued so we can convince the public that Oswald is the real assassin.
Convince the public? Like, how KPOC is that? Anyway, sounds like Mr. Hoover has taken some secrets to the grave, but the good news is there are some secrets I can share with you, like how we built this bot. So let's dive into the technical details. So before I do that, just to give you a little idea, we had this idea to build this bot like a week ago. And Wilson built the bot part, I built the model part, and we kind of came together, which is why he's here. So I'll have him, when we jump into testing the model, I'm gonna just have, I ask for his help to do that, so I don't have to do two things. we built a couple models, right? One is that synthesized voice, the other is the custom speech model, or the custom language model, and then we embedded it in a bot. So I'm gonna dive into that cryptonym one because all of us can relate to that. We all have companies or products or services, right? These names, acronyms, that if said to a default model, just wouldn't understand. So as a developer, this is something you can use to make a conversational bot work better than it did yesterday, starting now. And I think that's pretty important. So the first thing I'm gonna have you do or think about doing, right, is going and building out this language model. We start with the default language model and it's customizing it. So you don't have to build it from scratch, thank goodness, it would take a long time to do that. We're just adding to it. So what I did is I'm adding adaption model to adapt to the US model. And you'll notice here at the very top are all the utterances. Remember that lowercase g, lowercase p, floor I walk on? I go in and I say, how will the model typically pick this up? And I identify those utterances. And then I went in and said, okay, when you hear those utterances, here, this is the magic, right, that's happening right in front of you. Here is where I map it over to what I want it to be. I load that in to basically load the adaption data. I create a language model based on that data. You simply say create new and attach those two things you just created on the previous page. And then I create an endpoint. And now I'm ready to go. However, I know some of you are the type that like test your code in production, but I like to check my recognition before I put my code in a bot, specifically my endpoint to a language model. So let's, at the bottom of this page, when you guys go do this for yourselves, you'll see this test endpoint option. And so I created a series of audio files to test the recognition. So why don't we listen to one of them?
GP floor.
Okay, so it might have been like 2 in the morning when I did that one, but that's when all the good stuff happens. So I built a bunch of them, but in this case, I wanted to use that file to test the recognition just to make sure that the model is good. So now, in order for you guys to see that this is actually a real working model, let's go and do it in the site. So thank you, Wilson, for helping me. So we're gonna go to the audio file, right? There's the GP4 WAV file. I created it in Audacity, said open, choose test, and now it's going against that language model that I just created. And you'll notice, wow, awesome, right? It came back with GP floor, not just G space P space floor, but the GP floor, the cryptonym, the super secret, the Oswald, right? So this is magic when it comes to building a bot that's conversational. It can understand the language of your users. All right, so move it back. So now we've got our language model. We have this endpoint that was delivered to us. Now we need to get it into the bot. There are 2 projects in GitHub you'll need to clone. We've done a lot of this work for you to minimize the amount of effort to make your bots a little bit better or a lot better. Speech to text, Node.js. So you grab that project. There's also a web chat project that you want to grab as well. The first thing you'll want to do is change that endpoint, right? The host URL, which is that speech endpoint we just created. So you're just plopping that endpoint in here. Then the next thing, let's just pretend I had time to go through with the synthesized one, and then you would also add the synthesized, right? That's that custom voice, the voice that sounded like J. Edgar Hoover. That endpoint is provided here. Once you have both of those pieces, you of course need the keys in order for that stuff to work. So we add our subscription keys, and then finally we build that project out and piece those into the index.html client, ultimately just place it back into the client so it can leverage those resources we just changed. Right? It's that simple. It's a little bit of work, but it's not like what it used to be, right? I've built language models the old-fashioned way, and it was not pleasant, and it certainly couldn't have been done in a week, right? So a couple clicks in a web browser, uploading a little bit of data, and you now have a pretty decent introduction to customizing the language of your bot so that your customers can speak the way they'd naturally speak, say the brand names, the product names, the acronyms that they would normally say, and now your bot can truly understand them. Now we've talked about quite a few things, so I just wanted to point you to a few sessions in case you wanted to dive deeper. It is just day 1. So one is the first one, which is mine, I'm actually doing a session where I'll dive deeper on this on Wednesday. Then I also thought it'd be good if you knew a little bit more about bots, specifically NLU best practices in bots. So you might want to take a look at that. And then there's tons of theater sessions around the new speech services. So I put one of them up here, but certainly just take a look around the theater sessions. I think it'll be well worth your time. I certainly hope to see you out there, but in the meantime, I'll hand it back to Joseph.
You know, software application in the future will be nothing like what we use today. You're seeing the glimpse of the future with these apps. And so now let's talk about building your own custom AI models to transform business processes of all types. It usually involves 3 steps. Prepare data. Collect data of the type you want. More data, often the better. Join it, clean it, prepare it. Then build and train machine learning models on it for the tasks you are interested in. And then you deploy those machine learning models. The machine learning models capture deep knowledge from the data. You know, one thing to remember about machine learning models, it's not unlike mathematical models. See, in the past, when the world was deterministic, you know, physics, mathematics, etc., was able to have very clean, deterministic models of a phenomenon. Now, when you use machine learning and statistics, you're actually inferring statistical models from the data. And those models give you predictive power. It's not deterministic, but it's still statistically predictive. That's what you're using when you deploy machine learning models. Great. For each step of these, preparing data, building and training models, and then deploying them, we have the best-of-breed solutions on Azure. Let's think about the first one, step 1 of preparing data. Well, when you want to prepare massive amounts of data, one of the best platforms is Azure Databricks. It is an Apache Spark-based analytics platform optimized for Azure. It can scale dynamically. It can host data in memory, and it can do vast distributed computations across large number of virtual machines. It has rich interactive workspaces in which you can actually work and do all of that development in Apache Spark or PySpark or using Azure Machine Learning SDKs. And it has seamless integration with all of Azure's data services. So you can bring data in from Azure Storage, Azure SQL Data Warehouse, and so on, and transform all of that data and clean it up and prepare it for AI with the power of distributed computing in Azure Databricks. Now, step 2 of building and training machine learning models. Azure Machine Learning is your choice for that one. It supports a very broad framework of tools. It's not limiting you to a set of, a dozen or so pre-built models. It allows you to use TensorFlow and Cognitive Toolkit and Caffe2 and Keras and MXNet and Python. That openness is very important for enterprise developers. And you can scale training from 1 to hundreds of thousands of servers if you wanted, using the integration Azure Machine Learning has with Azure Batch. The Azure Machine Learning Python SDK makes all of this development very, very easy with commands. And that SDK can actually run in a data science virtual machine or in Azure Databricks. It is also my pleasure to introduce Azure ML Packages this time. Azure ML Packages for computer vision, text, forecasting, and these common scenarios make the development of vision models and text analytics models and forecasting much easier because these are much higher order libraries. And it provides automation of common workflows for the developer. So the heavy overhead of building these kind of models is reduced dramatically. And then step 3, deploying. When you want to deploy these machine learning models in production as web services, well, Azure Machine Learning allows you to export these as Docker containers with a command. And the model and other dependencies get packaged into a Docker container. And then you can use Azure Kubernetes Service, for example, to host it and scale it. So a scalable, auto-scalable collection of REST APIs. You can use Azure Batch if you want to run it in batch mode. Or you can use Azure IoT Edge and deploy it to the edge devices, like you saw today morning in Satya's keynote about edge-deployed drones with AI. Or any other container host. And so Azure Machine Learning is uniquely differentiated in that we are perhaps one of the few or the only company that allows you to build these machine learning models in the cloud and doesn't tether you to the cloud. You can take these containers and deploy it in the runtime environment of your choice. That's a unique differentiator. And to support all of this development, we have a great IDE. VS Tools for AI is an integrated development environment that connects into Azure Machine Learning. It makes deep learning much, much easier. You can monitor model training progress and GPU utilization, so you can be cloud connected. You can also, of course, develop on your own laptop, develop your code locally, and have it run in the cloud. You can visualize model performance with integrated open tools like TensorBoard, a very popular tool. And you can get started very quickly with samples in the gallery. A great IDE. So that's Azure Machine Learning. And we don't stop just with Azure services only. We are about empowering our developers with all the tools they need for AI. And so today it's my pleasure to announce a preview of ML.NET, which is a cross-platform open source machine learning framework for .NET. Now, this has been used internally at Microsoft. It has been in my team for multiple years and has been used extensively across Microsoft. And it's industrial strength. It provides you high productivity throughout the entire machine learning workflow. And it's even extensible to other frameworks like TensorFlow and C1TK. It's not actually a replacement for any of them, but you can extend into those. So you can find out more about it at that GitHub site. It's very, very powerful. Here are examples of the industrial strength production deployments at Microsoft today. For example, that feature in Excel of recommended charts, that's behind that is ML.NET. PowerPoint, Windows 10 security features, and even Bing uses ML.NET. So you're getting a very much the state-of-the-art machine learning framework. And now to Azure ML packages. Azure ML packages run inside Azure ML. They are pip installable. They are Python packages for computer vision, forecasting, and text analytics. They provide high-level APIs for data preparation, augmentation, training, evaluating, and deployment. And then model experimentation and comparison are also supported with all the features of Azure Machine Learning. So again, the best way to see all of this is with a customer scenario and demos. So now let me introduce a customer scenario. Now, Jabil is one of the world's largest contract manufacturers. And they use now machine learning for quality control. So what they do is to use machine learning to predict defects and automatically sideline circuit boards with defects so they can have a very high quality production pipeline in operation. Let me play a video to explain.
People tend to think of Jabil as a contract manufacturer. We are more than that. We're a manufacturing solutions provider. It's a very difficult business. We help customers with taking a product and building it at scale.
We went to the production site and found out the test machines suffers very high false call, around 30%.
Operators have approximately 2 seconds to analyze each one of these images. For some of the boards, they can have upwards of several thousand components on it.
Human gets tired constantly staring at the same stuff. We thought that was a very good opportunity for us to use deep learning to classify images. The model is actually reducing the workload for operator. For model training, we're using Azure Linux GPU VM, and we're using Azure Machine Learning Services to deploy the model as Docker container. Our pilot is predicting 75% of the past images and can correctly predict 92% of the defects.
It's one of the most advanced predictive projects that we've had going on so far.
Great. How would you build image classification models for quality control like this? let me invite Mark Hamilton, a software engineer in my team, to show you the demo. Mark?
Joseph. Hey Seattle, I'm Mark Hamilton, and today I want to show you how we can use the Azure Machine Learning package for computer vision to create a custom Jabil circuit board defect detector. Jabil creates circuit boards for high-performance industries like aerospace, defense, and energy. Each board they create contains hundreds, if not thousands, of different resistors, transistors, logic gates, every doodad under the sun. Each one of these particular components could suffer from a manufacturing defect, which could cause some serious consequences if not picked up early. We'll see how we can use the Jupyter Notebook, an interactive Python interpreter, and also a pretty snazzy Turing-complete replacement for PowerPoint to actually work through this example. The first step in our analysis pipeline is to load and prepare the data. In this particular cell, we'll import the computer vision package and point it at our data set. We can then split our data set into a training and testing set so that we can verify that our algorithm generalizes correctly to unforeseen data. As you can see, our data set contains about 14,000 images with 2 labels, pass and fail. But sometimes you might want to know a bit more than just how many images you have and what type of images you have. Sometimes in machine learning, you really need to get your hands dirty and dive deep into the raw data. Thankfully, this is fairly easy with the computer vision package. With a single line, I can boot up a results viewer, an annotation UI, that will display all of the images in my data set, and I can even interactively relabel them if I find any fishy labels. Luckily, though, our data set looks pretty good, so we can go ahead and move on to creating and training our network. The computer vision toolkit makes it fairly easy to make a state-of-the-art model. It only takes a few lines. So while this is cooking, let's take a look at what's going on under the hood. We use a technique called transfer learning, and the basic idea is fairly simple. When you start on a new vision task like playing Tetris or classifying circuit boards, you don't start by rewiring your entire vision system or changing the way your brain works all the way down to the brainstem. You just practice on a few examples and you leverage your past experience. Like you guys have all been telling apples from oranges in your day-to-day life for as long as you can remember, and you've gotten pretty good at it by now. So what's to stop you from taking that knowledge and using it to classify good and bad circuit boards? And at Microsoft, our algorithms are trained much the same way. We use a 50-layer deep neural network called ResNet 50. It's been trained on millions of images from cats and dogs to cars and boats and probably even Joseph Soros himself. We can then take this network and perform a little brain surgery. What we do is we cut off the final layer and replace it with our own scikit-learn model, and then train that final piece using Jabil's images. What this yields is an algorithm that can learn using only a small number of examples instead of a few million examples, and can train pretty quickly. As you can see, woohoo, it's done in like 20 seconds. That's not bad for a single machine. So now that we've actually gone and trained our network, we can explore what's going on and how it's actually performing. Previously, in order to set network parameters and understand how your network is doing, you need to print out lots and lots of different metrics, maybe copy paste them into an Excel spreadsheet, maybe make a couple dozen plots to understand what's going on. But today, you can interactively do it with the computer vision package. Here, you can interactively set the sensitivity of the model for what best fits your workload. In our scenario, I'll probably want to be conservative and set the sensitivity fairly high so that no defects get through to the final stages. Sometimes, though, it needs a little bit more than just setting the sensitivity to understand what's going on with the model. Sometimes you really need to dive into the results and see what the network is actually thinking. That's why the computer vision package comes with a results viewer. This tool will display will display each prediction that the network makes and lets us really dive into what the network is thinking for each one. We can even select the incorrect classifications to see how the network is doing on the toughest examples. This lets you really go in and diagnose the network where it has the most trouble and helps minimize the dev loop from creating your model and training it to actually understanding what's going on. And this really helps when you're trying to get to production quickly and trust what you bring into production. Once you're satisfied with your results, we can go ahead and move this thing to the cloud. With a few lines, we can deploy our model, wrap it up, Dockerize it, and throw it up into a Kubernetes cluster. A Kubernetes cluster is a large network of computers where each node is fault tolerant. That means that if a tornado rampages through your deployment and you still have some nodes left, it can still stay up and keep serving predictions like nothing happened. This particular cell takes about a minute or two to run, so I've gone ahead and already deployed it so we can check it out. Now that we have our model in production, it's time to really put the spurs to it and send a couple thousand images at it. Here, I'm loading in a new validation data set that contains about 1,000 images. And within a few seconds, we can kick off a speed test that will show us in real time its predictive ability and also its throughput. As you can see, we get about 250 images per minute, which is fairly good considering that this example is I/O bound, which means that if we had 6 of these notebooks up here all sending data up to the service, we'd still be able to perform this demo without more than a hiccup. This particular workflow is just one example of the several different workflows possible with the computer vision package. The computer vision package has primitives for creating your own image similarity pipelines and also creating real-time object detection systems on your individual data sets. Furthermore, this is just one particular example of the 3 packages that we've made public today. In the text analytics package, you can do things like cluster your documents based on what's actually inside them, or even create your own custom entity detectors on your own data set. With the Azure Machine Learning package for forecasting, you can take your time series data and do things like extract the seasonal trends and even extrapolate them into the future with confidence. And the best part is that all of what you've seen today, the notebooks, documentation, examples, code snippets, all of it's made public at aka.ms/AML packages. So you can go ahead and get started and relatively quickly put these kinds of powerful machines to work on your own data set. And if you like, you can even do this all through Visual Studio Tools for AI. Thank you very much for your attention, and I hope you enjoy the rest of your build.
Awesome demo. Now, we can take such applications to an entirely new level of performance with special purpose hardware. So it's my pleasure to talk today about the integration of Azure Machine Learning and Project Brainwave. Project Brainwave is really an architecture for running neural networks efficiently. The first instantiation of that architecture is on FPGAs. FPGAs deployed in the cloud with neural networks embedded in them, and it speeds up neural network evaluation dramatically. So for example, ResNet 50, one of the commonly used image classification models and featureization models, it runs in less than 1.8 milliseconds per image. FPGAs are particularly good when you're scoring image by image, single image at a time, which is what you want if you're doing real-time AI. And it does so at the lowest cost, only about 21 cents in the preview. And we will have more accelerated models like ResNet 50 coming soon. And when you integrate all of that in an Azure ML model, in an Azure ML development process like you saw Mark Hamilton do, you can actually get a web service hosted in the cloud which is capable of scoring individual image at a time with extremely low cost and low latency for true real-time image analysis. So Jabil is excited about that capability. Let me play a video.
We've been talking with Microsoft about Project Brainwave.
The early test result from Microsoft has shown FPGA is capable of predicting 550 images a second, comparing with a CPU cluster with 40 images a second.
The potential for Project Brainwave is substantial in allowing us to move forward at scale for machine learning across Jabil. Very exciting.
So let me show you a demo of that as well. And so here is the structure of the demo. Jabil's images are in Azure Premium Storage. So then you build these classification models using Azure Machine Learning, and you train, and you deploy them as web services, and it's running on an FPGA. So let me now invite Ted Way, who is a senior program manager in my team, to show you this demo. Ted?
Needed to change the resolution on my screen here. Thank you, Joseph. As you've been hearing, it's relatively easy to infuse AI into your apps. The hard part is making it run super fast. With today's announcement, we're excited that you're able to create and deploy AI models onto Intel FPGAs for ultra-fast scoring. And now, with Azure Machine Learning, hardware-accelerated models powered by Project Brainwave, you have the selection of being able to deploy to CPUs, GPUs, or FPGAs. So I'll continue on with the story of how we use this to be able to identify manufacturing defects in images of assembly line items that Jabil is using. And I'll be speaking to two audiences today. First are the data scientists, how you can easily create and train and deploy that model. And second, to the developers, how you can consume that model as an API in your apps, all without writing one line of Verilog code. So I'm going to jump over to my environment here. And apologies, my screen resolution is a little off, so I'm just going to play the video so that you'll be able to see what it's showing. As you can see here, this is a familiar environment. This is just a Jupyter notebook. This is Python and TensorFlow code. Change this over here. This is Python and TensorFlow code. And then what we have here is a ResNet 50 that's been quantized. And this enables you to be able to run this model on CPU and GPU for your featureization. Featureize your data on CPU and GPU, spin up a CPU or GPU cluster, featureize that data, take those features, and then train your classifier. Once you've trained this classifier, what we do is we package that up into a service definition, and then with only one line, we can deploy that onto an FPGA. So in this deploy section, you can see here that the deploy client, you can deploy that onto an FPGA. Now let's take a look at the API that you can get back. So to all the developers, you have an API that you can run. So I'm going to run through in this notebook that you just saw. And I have an image here that I want to send up to my API. This image right here, I'm going to predict whether there's a manufacturing defect in there or not. Let's click run, and there you see it. In less than 15 milliseconds, this image left my client machine, traveled to the API, got converted from a JPEG into tensors, ran the 8 billion calculations required for ResNet 50, took those features through a classifier, and sent back the results back to my client machine in 15 milliseconds. For a CPU, that would be about 150 milliseconds. So this is about 10 times faster than that. So let's take a look now on what this would look like on an app. So if I were to open up an app that we built, comparing the performance of a CPU and a box that has CPU plus FPGA. So on a CPU, I'm going to start sending images up there. I'm going to increase the number of threads just to try to send more images to that CPU model. And the needle, you can see, is probably about 6 images per second. So let's see what happens if we send this to the FPGA. There you have it. What's happening now is I'm using one thread to send as many images as possible, one at a time, and for each image, latency of about 6 or 7 milliseconds. This is really real-time AI. So let's try to slam this API with as many images as possible and kick up the number of threads here. Now check it out. 550 images per second. Average latency, median latency, about 14 milliseconds. I showed you how you were able to use Python and TensorFlow and how you're able to easily create and train, deploy a model running on an Intel FPGA. And now, with this API, you're easily able to infuse that into your app. So what are you waiting for? Go check out our GitHub repo, write some code, deploy your first FPGA service, and unleash the power of real-time AI. Thank you.
Imagine all of that compute power in the cloud at your disposal to analyze the world around you. So at Microsoft, we are exploring applications of AI in a variety of areas that could benefit us all. We started the AI for Earth program to fundamentally transform the way we as humans monitor, model, and conserve Earth's natural resources. For example, what if we could automatically see the trends through satellite imagery of human development, of depletion, of conservation needs, of water availability, and so on? And right now, if you're analyzing satellite images, a human being actually goes through each one and tries to understand what the image shows. There are no easy-to-use automated tools for it. We can change that with AI. Now imagine you had a large collection of freely available satellite imagery, and maybe a portion of that is labeled by somebody. They identify water bodies, forests, and rivers, and houses, and so on. This is your training data. Now you can use the same process that we used for Jabil to learn a machine learning model, and then you can deploy that machine learning model on an FPGA, and with incredible price performance, comb through the vast amount of satellite imagery that you have to understand what's going on our planet. And we did just such an experiment. So here's the setup. We had 800 FPGAs on Azure, 195 million images. This is the satellite imagery of North America. Imagine it's all of North America, and every pixel is about a few meters. We had 20 terabytes of data, and we sent these images through the FPGA, one image at a time, so that the FPGA could score for what each individual pixel in that satellite imagery stood for. So you can deeply understand what's in the image. And here are the results we got. We could do 415,000 inferences per second at 1.8 millisecond latency. It took only 10.6 minutes to score the entire North American continent and get deep understanding of what's in that satellite imagery. It's an order of magnitude better price performance over CPU and GPU. This is massive. This gives us the ability to understand everything on our planet. And that's the kind of capability Azure now enables for us. Learn more about this. There are 3 sessions, such as the hyperscale hardware, Azure FPGA with Doug Berger, will give more details about the capability and what the future holds here. Very, very exciting. So here's what we demonstrated today. We showed that with capabilities like cognitive search, you can build modern applications that understand every type of data. It does content-based indexing, search, and analysis. Using Azure Bot Services, you can build conversational apps that engage with users in very, very natural ways, through speech and voice, and language understanding. Then using custom AI with Azure Machine Learning, you can optimize business processes and even build ultra-scale, real-time web services on the cloud for applications for your tier 1 needs. Very powerful. So now I would love to introduce a partner we are working with. Computer vision scenarios are often very helpful in applications of predictive maintenance and fire safety and so on. And DJI is one of the world's leaders in building drones that help empower all of these type of scenarios. So let me now welcome Roger Luo, who is the president of DJI, on stage to have a conversation with us. Roger,
hey,
welcome.
Yeah, nice to meet you.
So Microsoft and DJI have been using AI in our products for quite a while. How does DJI apply AI?
Yes. DJI use AI across all the products to create the streamlined user experience. You can see that the drone on my hand is DJI Mavic Air. You can see that the size is very compact. However, through AI technology, the flight experience of users is extremely stable, no matter you fly it indoor or outdoors. In addition, AI also enables advanced features for this system. For example, gesture control. That means you can control a drone with your hands, no matter you fly it up, down, left, right, forward, backward, or even take the pictures or videos.
It's amazing. So just by with your hand gestures, you can control how it flies.
Yes, exactly. And we have another function, is obstacle avoidance, which prevents the drone flying into the trees or hitting other obstacles. And we have the object tracking function. This means the drone could follow you automatically.
That's great. So how does the partnership between Microsoft and DJI help developers?
Yep. Today, we just announced the new SDK for Windows. The SDK provides all basic functions, including flight control and the real-time data transfer. In addition to this, it allows the native Windows application to interact with our drone directly. Then you can combine this with Microsoft IoT Edge. But of course, today the time is somehow limited. So I would like to invite you to join another session that will take place at 10:30 tomorrow morning at TCC Tanuma 4.
Okay, that's great. So what kind of new commercial applications is AI enabling with drones?
Yep. We do see a lot of industry verticals using drone now. And drone, like we use AI for the consumer products, in commercial applications, AI make our product even stronger. So I would like to have a very specific introduction of how you use.
Yeah.
Yes, please.
We should play a video, right?
Yes, please. Yes.
Can we show the video up here?
Yeah,
it's a very good illustration here.
Yep.
Of the
Never miss the heat with Temp Measure, allowing pilots to get detailed temperature data in real time. Quickly interpret this complex thermal information with FLIR MSX technology and isotherm controls, letting you overlay visual data on top of thermal imagery and fine-tune your real-time view.
It's very important for us to be able to confirm quickly what we're seeing on the thermal view. With these new real-time visualization settings, we can immediately interpret this aerial data and quickly make detailed tactical decisions on how to proceed with our rescue operation.
So the AI here locates the heat and automatically flies the drone and keeps it localized.
Exactly.
Right.
So I hope the video will be quite helpful when you try to combine AI and the drone together.
That's very, very powerful. Thank you for joining us.
Thanks for having me, Joseph. Thank you.
Big hand to Roger, please. So predictive maintenance and inspection of every type of infrastructure is going to be enabled by capabilities like this, drones and AI coming together in amazing ways. So DJI is using Microsoft's capabilities to empower their scenarios. Let me give you 5 reasons why you should, as a developer, build your next AI app on Azure. The first one is that Azure offers the broadest set of pre-built AI capabilities that makes that development process very easy. Many of the demos that you saw in my session, a skilled developer could build in a matter of weeks, just one developer, and deploy them on the cloud as hosted services. We have customization for these pre-built APIs. No other cloud gives you the level of customization we do, whether it be for speech or language understanding or translation. In fact, you can build your own translator using Azure's translation APIs. We also have the most advanced conversational AI. Our language understanding is powered by machine learning. They're not powered by just rules. And there is a number of features that are built into our conversational AI platform that leverage the latest advances in AI. Even capabilities like having chit-chat and learning from conversations automatically and improving. Those are all in there. Then the fourth thing is that we have the most differentiated support for AI at the edge. You can build your AI models in the cloud, host them in these edge devices, and manage them, and monitor them, and upgrade them, and do all of that with the power of the cloud. And finally, with the power of all the data services that we have, such as Databricks and Azure SQL Data Warehouse, and hardware like FPGAs, and identity and monitoring, and all the other support that is there in Azure, we are truly the strongest enterprise cloud for data and AI. And you can build the best mission-critical applications and deploy them globally through Azure's incredible global reach. So don't wait. Become an AI developer on Azure now. Leverage all of this incredible power. Let your imagination roam free. Thank you all. Thank you very much.